Alright, so let's look at our example B. The bar graph shows a football player's home run totals. What was the percent of change from 2012 to 2013? So we need to look at this chart. Okay, so if we look at the chart and they're asking us from 2012 to 2013. So let's look at our 2012. So this football, I'm sorry. Oh my gosh, did I put football? I did. Oh my gosh, I'm so sorry. Okay. Bloop, 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 bloop. Softball. I apologize. This softball player's home. So just correct that. All your copies are going to might say softball, or hopefully I'll be able to change it before I hand it over to you. But on here it says football. It's supposed to say softball. Okay, so softball player. The softball player made several home runs in 2012, they made 28 home runs, this person. And then in 2013, this person made 20 home runs. So we have to think about, did it increase or did the quantity decrease? So if going from 2012 to 2013, the amount went down. It went from 28 to 20, so it went down, which means that it decreased. So since the number of home runs decreases from 2012 to 2013, so the percent of change is a percent of decrease. And again, the formula for that is the original amount subtracted by the new amount, all divided by the original amount. So for these numbers, we're looking at the percent of change from 2012 to 2013. So we take the original amount. So the original amount is 28 minus the new amount, which is 20, all divided by the new amount, which is, again, or not the new amount, so I apologize, by the original amount. I'm just going to cross that out. Okay, so 28 minus 20 divided by 8. 28 minus 20 is 8 divided by 28. Remember, it's all divided by the original amount. Okay, so let's divide 28 into 8. Let's see how many times it can go into 8, because remember, it's the numerator divided by the denominator. So 28 can't go into 8, so we gotta put a decimal, add the 0. Okay, 28 goes into 82 times. 28 times 2 is 56. 80 minus 56 is 24. I know that because if I do all the calculations, it's 24. So I gotta bring down a 0. 28 goes into 240 8 times. 28 times 8 is 224. I'm running out of room here. 10 minus 4 is 6. 3 minus 2 is 1. Then we got to bring down another 0, and I'm going to stop here. 28 goes into 166 times. And I'm going to stop there because I know this is one of those decimals that's just going to keep going, 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 and going. Okay, so we know that it's 286 thousandths, okay? Or 0 and 286 thousandths. But again, that's the decimal, so we gotta turn it into a percent. So we gotta move the decimal twice to the right. So we're left with 28 6/10%. Okay, that's our percentage, 28.6%. Okay, so our percent error. Let's look at how we figure out percent error. So percent error is the percent that an estimated quantity differs or is different from the original amount or the actual amount. So meaning, let's say you estimated that the movie was going to be 2 hours and 30 minutes, but the actual length of the movie was only 2 hours and 20 minutes. So that you would need to find your percent of error. Okay, so for example C, you estimate the length of the classroom as 16 feet, but it is actually, its actual length is 21 feet. So find the percent error. So, and I apologize for all the errors in this paper. I'm going to correct it before I give it to you, so you won't see all these errors. So you estimate the length of the classroom as 16 feet, but the actual length of the classroom is 21 feet. Find the percent error. Okay, so first we got to find the amount of error. So we got to subtract the actual length, which is 21, by the length of the estimation, which is 16. So 21 minus 16 is 5 off the top of my head, 5 feet. Okay, so the percent error formula is the amount of error divided by the actual amount. Okay, so if we look at our problem right here, the amount of error, 21 minus 16, is 5, divided by the actual amount, which is 21. So we got to divide 21 into 5. So 21 can't go into 5, so we got to put a 0. Put the decimal up. 21 goes into 50 2 times. 2 times 21 is 42. 50 minus 42 is 8. Bring the 0 down. 21 goes into 80 3 times. 3 times 21 is 63. 80 minus 63 is, let's do that really quick. 10 minus 3 is 7. 7 minus 6 is 1. Bring down the 0. 21 goes into 170. 8 times 21 times 8 is 168. 170 minus 168. It's all 0. And I'm going to stop there because I know that for percentages, we just need to bring the decimal 2 times to the right. So I'm going to stop right there because I know that this decimal is going to just go on and on and on and on and on. And again, if your decimal goes on and on and on, you will have your 2 decimals. You know that the decimal will only move 2 places to the right, and sometimes the problem will say round to the nearest 10th if necessary, and that's what you'll have to do. You'll have to get to the 10th place, or actually to the 100th place, and then you'll see if that number is bigger or smaller, or if that number is above 5, then you round up. If that number is below 5, you round down. Okay, so that's how you would get that. But I'm going to stop right there, and I'm going to put 0 and 238 thousandths, or the percentage, again, you got to move the decimal 2 times to the right, is 23.8, or 23 8/10%. I'm going to write that a little bit bigger so you can see that. Okay, so now it's time for you to try this. Find the percent of change. So you're going to find the percent of change for 57 people to 65 people. Tell me it's a percent of increase or decrease, and then you need to tell me what the percent of change is, okay? Once you're finished with that, you need to move on to the worksheet that I'll be passing out. And then once you're finished with that, you can move on to Khan Academy, okay?